So in this video we are going to discuss matrices, exercise 3b, section 1, fifth problem. If A is equal to I0, 0 minus I and B is equal to 0 minus 1, 1, 0 and C is equal to 0, I 0. So, and I is the unit matrix. So here capital I is the unit matrix. Capital I is the unit matrix of order 2. So then show that. So first of it, A square is equal to B square is equal to C square is equal to minus I. And second one is AB is equal to minus BA. And also which is also is equal to minus C. So now in the solution, given that the matrices capital A is equal to I0, 0 minus I, B is equal to 0 minus 1, 1, 0 and C is equal to 0, I 0. See, in the first bit what we have to find? We have to find the A square. A square is equal to, we know that. So A into A, which is equal to, so I0, 0 minus I into again I0, 0 minus I, 0 minus I. So which is equal to here. So directly multiplying, see here, first row, first column, I into I, that is I square, and 0 into 0, that is 0 plus immediately 0. And first row, second column multiplying, I into 0, that is 0. And first row, second element multiplying 0 into minus I, so that is minus I. Again second row, first column multiplying 0 into I, so that is 0. So minus I into 0, that is also minus 0. Now second row, second column multiplying, so 0 into 0, that is 0. So minus I into minus I, so that is immediately plus I square. See, when you multiply two elements, immediately you have to keep the plus sign. So once again I into I, that is I square, plus 0 into 0, 0. Again I into 0, 0. And plus 0 into minus I. So plus into minus is minus, so that's why minus I. Again second row, first column. So 0 into I, that is 0. And minus, actually plus into minus is minus. I into 0, 0. So again second row, second column, 0 into 0, 0. And plus minus I into minus I, that is plus I square. So which is equal to A square is equal to, so we get here I square. So here, so 0 into I 0 and minus I into 0 is also here 0 only we get. So that's why, so here also 0 we get and here 0 we get and here I square. So we know that I square value is minus 1. So that's why which is minus 1, 0, 0, minus 1. So which is equal to, if you take minus common, so we can write 1, 0, 0, 1. So which is equal to minus I. So since I square value is equal to minus 1. So similarly we can find the B square also. See here B square is equal to, so B into B, so which is equal to the matrix B is we have 0 minus 1, again 1 0, so into again 0 minus 1, so 1 0, so which is equal to, so first row, first column multiplying 0 into 0, 0 plus and minus 1 into 1, that is plus into minus is minus 1. So 0 into minus 1, that is 0. Again minus 1 into 0, so that is also 0. So that's why which is a, so first row, second column multiplying. Second row, first column. So 1 into 0, that is 0. And plus 0 into 1, 0. So again 1 into minus 1, minus 1. Again we have to keep that plus 0 into 0, 0. That's why second row, second column multiplied. So we get B square is equal to also here. See, this is 0 minus 1 and 0. Again 0 minus 1. Again you can take minus common. So 1 0 0 1. So which is also is equal to minus I. So here also I square is equal to minus 1. So that's why here. So replace it here. Here there is no I. So that's why there is no problem at all. Now C square is equal to C into C. So which is equal to matrix C is so 0 I 0. So again into so 0 I. So I 0. So then if you multiply these two we get so first row first column 0 into 0 0 plus I into I, that is I square. So first row second column, that means 0 into I 0 and plus I into 0, that is also 0. Again second row first column I into 0, that is 0 plus 0 into I, that is also 0. So again second row second column I into I, that is I square and plus 0 into 0 0. So we get C square is equal to, so here we get I square, so 0 and 0 I square. Again we know that I square value is minus 1, 0 0 minus 1, so which is equal to minus, so 1 0 0 1 we can write, which is also is equal to minus I. So therefore clearly we can write therefore A square is equal to minus I, B square is equal to minus I, C square is also is equal to minus I. So therefore A square is equal to B square is equal to C square is equal to minus I. We proved that. So which is the solution of the first bit. See, A square is equal to B square is equal to C square is equal to minus I. Again what we have to prove? We have to prove that so second bit, so AB is equal to minus BA is equal to, which is also is equal to minus C. So now find AB here, the second bit, so AB multiplying A into B. So the matrix A is, so I 0 0 minus I, so into matrix B is here, so 0 minus 1 1 0. Multiply both which is equal to, so first row first column multiplying, so I into 0 plus 0 into 1, again first row second column multiplying, I into minus 1 plus 0 into 0. So here second row first column, so that is 0 into 0 and plus minus I into 1. Second row second column 0 into minus 1 and plus minus I into 0. So what we get, which is equal to, we get here 0 plus 0, that is equal to 0. See, 0 plus 0, that is 0. Here minus I plus 0, that is minus I. So which is minus I. And 0 plus minus I into 1, that is minus I. So which is minus I. And here, so 0 and here also 0, finally we get 0. See, this is AB. So AB is equal to 0 minus I 0. See here BA finding. So BA is equal to, see BA is equal to the matrix B is 0 minus 1 and 1 0 into, again matrix A is I 0. So 0 minus I, now multiplying these two which is equal to, so 0 into I plus minus 1 into 0, minus 1 into 0, and again first row second column 0 into 0 plus minus 1 into minus I we get. So then second row first column, that is 1 into I and plus 0 into 0. And second row second column, that is 1 into 0 plus 0 into minus I. So finally we get which is equal to, see here, so 0 this is and it is also 0. So now here 0 plus I, that is equal to I, and here I plus 0, that is I, and 0 plus 0, that is equal to 0 only. See here, so AB is equal to minus BA. So AB is equal to prove the minus BA. So here minus BA is equal to now. What we get? So if you multiply minus BA matrix is what? 0, I 0. So which is equal to, so minus, so here if you multiply these elements with minus, what we get here? 0, minus I and minus I 0. See, observe here. AB is we get 0, minus I 0, and minus BA is 0, minus I 0. So that's why we can write AB is equal to minus BA. Therefore, AB is equal to we can write minus BA. And also here we have AB is equal to see here 0, minus I and I. So here 0, minus I 0. Then if you take here minus common, we can write 0, I 0. So which is equal to, we can write minus C. Observe here. So 0, I 0. That is, we have C. So that's why that is minus C. So therefore here AB is also is equal to minus C. So finally we can write, so therefore AB is equal to minus BA is equal to minus C. So like this we can prove the second bit also.